In this video, we're going to build a driver matching system using AWS. We will implement it using API Gateway, Lambda, and Redis ElastiCache. Lambda used to process the request from driver and rider, ElastiCache to store driver location and perform geospectral query. Let's start by setting up the AWS infrastructure. The first thing we need is an IAM role for our Lambda function. Let's search IAM in the console. Go for role, create new role. We're going to create this for Lambda. Next. So we need to attach the policy here. Since Lambda will run inside a VPC and to connect Redis, it needs two permissions. The first is a basic execution role and second is a Lambda VPC access. Okay, so we'll search for both. Lambda. Okay. Lambda basic execution. And second is VPC execution rule. Okay. Next. Let's name it Uber. Okay. So we attach the required policy here. Let's create a role. Okay. Role got created. Next, we create a security group for Lambda. We'll search security group. Okay, create security group. I will name it as Lambda Redis security group. This security group does not need inbound rules because Lambda does not accept incoming traffic directly. So inbound rule is not needed. Instead, it only needs outbound rule, so it can connect to Redis inside the VPC. So all traffic is fine for 00 destination. Yep, everything is fine here. We don't need any inbound rule. That's great. Okay. For Uber. This for Uber case study. Great. Alright. Security group was created. Now we'll create one more security group for Redis. Create security group. Let's get Uber case study. Okay. This security group, we configure Redis to accept traffic only from the Lambda security group on port 6379. Okay. This ensures only Lambda function can communicate with Redis. So we need an inbound rule in that case, and it should be a custom TCP, and port is 6379, and source will be the security group which we created previously for Lambda. Outbound rule. Create security group. Alright, we have created two security group, one for Lambda, another for Redis, and it created successfully. Alright, next we will create Redis instance using ElastiCache. We'll go to console, go for ElastiCache. I'm going to use Redis, create cache. We are going to use the serverless Redis option, which automatically scales and manages nodes. customize the setting. I'll be using the default VPC, and subnet is, I will use these two subnet, 6A and A7. Customize the security settings. So now we need to choose the IAM here. We need to choose a security group which we created. I'll be choosing the Redis security group which we created previously. Because via this security group only, right, Lambda can able to communicate to this Redis. In such a way we are configuring this. Okay, let me confirm that. Documentation, Redis security, Redis cache. Yep. So everything is good here. Let's create. It will take some time. Let's wait for a minute until the status changes to created. So now Redis created successfully. The next step is we're going to create a Lambda layer for Redis. Okay, the reason why we need to Lambda layer is by default Lambda don't have any Redis package. Via Lambda only, right, we're going to communicate with Redis. So in order to import the Redis package in Lambda, we need to create a Lambda layer. Let's start creating the Lambda layer. So first let's make directory. I will include this documentation link in description so you can use this. Okay, and now I just need to install Redis in Python directory. Fine. Okay. Okay, I will zip this one. Okay. Okay, this is the zip which I need to upload as a Lambda layer. Let's go to Lambda. Lambda. Layers. Create layer. Where is Python? For case study. Let's upload a zip file which we created. So this is a zip file. Let's keep things default. Great. We'll give a minute. Now Redis layer created successfully. So this is a new one which we have, which we're going to use. Okay, now we will create a Lambda function. So we're going to create two Lambda function. First, we're going to create a Lambda function which help us to ingest data to ElastiCache. Let's go to Lambda functions, create function. Okay, I will name it as Uber ingest function. I'm going to use runtime as Python. Okay. So we already created a role for this previously, right? Which we're going to use it. So the role is Uber role. And in the additional configuration, here I need to make this Lambda to be get communicated to the ElastiCache. So right, this Lambda should be part of the VPC. I will choose enable VPC, and the subnet is okay 6A and A7. This is what something we choose for Redis one. And security group is Lambda Redshift security group. Okay. We already created this security group previously. Okay, create function. So I have a checklist here. So we have configured this. Now we need to set up the environment variable and then the Lambda layers, and then we need to attach the API gateway and we can test it. Okay, fine. Let's go. Okay. So Lambda is getting created. So in the meantime, let's wait until it's get created. So again, I'm repeating, this Lambda will receive a driver location and store it inside the Redis. Okay, we're gonna send an event by API gateway for this scenario. Okay, so Lambda created successfully. Now let's go and modify the code. Before we modify the code, first we'll understand the Lambda code, which I already created. I will share this code in the description. You will be able to find the link. From there, right, you can reuse this. Okay. So this is the Lambda injection code. Okay. So first, this Lambda will actually receive a API request. For where API request as an event, we'll be extracting the body. Okay. And from the body, we are able to extract the driver ID and then latitude and longitude. Okay. And here is the important thing. Using the GeoAdd command with the Redis client which we creating above, we will be adding the latitude and longitude and then the driver ID using the GeoAdd command. Okay. So this is how we are actually inserting the record to Redis. Okay. And if you see here, right, I was actually configuring the Redis client here using a Redis module. For this Redis module only, right, we need to attach the Lambda layers. Okay, let's copy this code. Deploy it. Okay, deployed. Now we need to create the environment variable. To do that, just go to configuration, environment variable, edit, add environment variable. Okay, this is the environment variable, and for this we need to give an endpoint. Now I will be able to get the endpoint from the ElastiCache console. This is the endpoint, so I don't need put. Okay, so now environment variable was set it up successfully. Let's check the to-do list. Name, environment variable, VPC, subnet, security group. We configured everything. Now we will attach a Lambda layer. Okay. So adding a Lambda layer was pretty easy. We already created a Lambda layer. We just need to come down, edit, add layer, specify the ARN. Okay, let's copy the ARN first thing. So I'll copy this ARN with the latest version. Add layer. Let's verify. Okay, this is the Lambda layer which we need to add, which actually have the Redis module. Okay, add layer, save. Okay, now Lambda layer got attached to this function. Fine, let's refresh and see once. Okay, fine, everything is good. Next, next thing what we need to do, right, we need to we'll just increase the timeout alone, because mostly, right, there won't be any latency, but just for safer side, right, I will just increase the timeout alone. Save. Then now we'll attach the API gateway. API gateway. Create a new API gateway. It's a REST API, and I will keep it open now so that we can test it. Add. Fine. We have the API gateway attached to Lambda. we have the code which got deployed successfully, and we also configured the VPC security group IAM and then the subnets. Everything is configured successfully. Okay, Lambda layer is also attached. Now let's try testing this Lambda function. Okay, to test this Lambda function, I already created a client file for this. So what I'm going to do, right? First, let's get the endpoint, API endpoint. So this is the endpoint which I need. I'll copy this one. Okay, this is the endpoint. Now let me activate the Python environment. So I already created a Python environment. You have the documentation here. You can also reuse this. Let me. Okay, I activated it. Okay. In the client side, I will explain the client code now. So this is the URL, and I have a function called send driver location, which will expect driver ID, latitude, and longitude, and this is the payload. With this payload and with this API URL, we are sending a request to this endpoint. Okay, let's run this code. Okay, client. Okay, so we got a response back from the Lambda telling that driver location updated, driver ID is D1. Okay, so we are able to ingest the data to Redis now. Okay, I also have one more script which is simulate API request, which is also we can use it for ingestion purpose. So this script I will explain what we are doing here once again. I will again replace the endpoint. Okay, what this script is, right, instead of manually sending a request one by one, this script randomly moves drivers slightly and send location updates every few seconds. Okay, that's what I've written. So it will actually randomly shifts the latitude and longitude, and it will choose the drivers randomly from the list, and based on the base latitude and longitude, the location will be get shifted, and I will be creating the payload, and with the help of the payload I was giving the request. So right, I tried to mimic much similar behavior in real life, but this one will help us to ingest few records which later we can use it for searching purpose. Okay, let's execute this one. Python. Okay, so for every 2 seconds we'll be started inserting the records. Okay, let's go and monitor the insertion from the Elasticsearch, sorry, from the ElastiCache console. Go to ElastiCache console. We have a tab called monitor, which will show us the data movement. So if you see, right, these are the data size was too small, so that's why it's showing you in bytes. But if you see here, right, clearly, right, there is a data movement happening, which means like we are ingesting the data to the ElastiCache. Okay, so our ingestion job is working as expected. Now we will create our second Lambda job, which is used for proximity search. Let's go to Lambda dashboard. Okay, create function. We'll name it as Uber search function, and runtime is Python. So we already created a role for this, which is a Uber role, and go for additional configuration. Here also we need to access the Redshift. So it should be part of the VPC. Okay, because the Redshift was part of this VPC. Okay, we need to choose a subnet 6A and A7. These are two subnet, and security group is Lambda Redis SG. Okay, so we created all the security group as well as the IAM role previously, which we are reusing now. Okay, that's it. Let's create a function. Okay, the function got created successfully. Let's deploy the code for the search. Okay, it is Lambda proximity search code. We'll explain the code first. Okay, here also, right, we'll be getting event from the API gateway. From the event body, we'll be extracting the latitude and longitude, and with the help of this latitude variable and longitude variable, we are using a function called GeoSearch, which is which will help us to find the which will help us to do the proximity search for the given latitude and longitude. And the radius which we gave is by default it will be a 5 kilometer, and then right which will also there is a attribute called with distance equal to true, so which will actually return the distance key point as well in the response field. Okay, so this is the Lambda function for the proximity search we're gonna use, and this GeoSearch was part of the Redis client which we created above. Okay, I'll copy this, deploy. Okay, okay, code got deployed. Now we'll go to configuration. We'll change the runtime alone to 1 minute, and now we also need to create an environment variable for the Redis client. Okay, add environment variable because we are accessing the endpoint from the environment, and we need to pass the endpoint in the value. We don't need port number because in the code itself we are hard coding the port number. Save. Okay, let's go and check the checklist. So we created the Lambda, second Lambda. Environment variable was set up, VPC, subnet, security group was there. Now we need to attach the Lambda layer. Okay, so again it was pretty straightforward. We already know how to attach the Lambda layer. We did it for the previous Lambda. Edit, add layer, specify ARN, copy this ARN, paste it here. This is the Lambda layer ARN. Verify it, add, save. Okay, now layer got attached. Okay, okay, what else we are missing? Lambda layers attached. Now we can attach the API gateway. Okay, so add triggers, go for API gateway, create a new API gateway. Let's make it as a REST API, and then right, we'll keep it open. Add. Okay, so the API gateway also got attached. We also configured the VPC settings, security group, subnets, Lambda layers, everything got attached, everything got created for this. Now let's try to test this code. Okay, so to test this, I have created a client file here, which is this one, Redis search client. Okay, so what I'm doing, right, first I need to get the endpoint here from the API gateway. So this is the endpoint. I will replace it in my code. Okay, okay, so the payload will, for on this endpoint I will be passing this payload. The payload is latitude and longitude with the radius of 5 kilometer. Okay, so If I execute this, what it will do, right? It will use this payload extract the payload from the body section, and with all these parameters, with the help of GeoSearch command, it will search the nearby latitude and longitude from the Redis client. Okay, so this is how the proximity search works. Let's execute this. Python Redis. Okay, fine. For the given latitude and longitude, from the output we can see driver 1, driver 2, driver 3, driver 4, and their closest distance and their distance. Seems like driver 2 was too close for this latitude and longitude. So most probably, right, driver 2 will be get assigned to this client. Okay. So now we have a working proximity search system where driver sends their location updates, Redis used to store the coordinates, and rider can actually request for a ride, and the system will be able to find the closest driver. So we implemented all these things. But in real system, driver updates come from high volume streaming pipelines like Kafka, Kinesis from there instead of an API. Okay. In next video, we will implement a real-time Redis update using a streaming architecture to make the system production ready. If you like our video, add your comments and keep supporting us always. Thanks again.